Okay, so here we have for example 10.2, we had a similar problem like this in 9.7. We're actually going to use the same setup, but instead it's going to ask us to find the magnitude of the acceleration of the cable, like the magnitude of its acceleration. So in order to do that, we have to know a few things. First, we have to know that there's going to be a weight force that's going to balance the unwinding out, and the normal force is going to be going this way. And this over here is supposed to be the radius, and that is L, right? And we know that from the previous example, right? So we know that the radius is equal to 0.060 meters. We knew that from the previous example. That's going to be equal to L. Right, so now to find the acceleration, we have to find the torque. So the torque is going to equal the torque is going to equal the force times the L, which we know that's going to be 9 newtons, which is given to us in the problem. 9 newtons times 0.060, which is going to give us 0.54 newtons times meters, right, per meter. By meters. Okay, so now to find the moment of inertia, we did this in the previous problem too. It's going to be 1/2 times meters r squared. Sorry, not meters, mass, my bad. Mass r squared. And so using what we have in the problem, we have that it tells us that it's 50 kilograms. It has a mass of 50 kilograms. And so it's 50, and we have the 0.060, which is the radius. And this is actually supposed to be squared over here. Supposed to be squared, right? And then you do those calculations, and you get 0.090 kilograms by meter squared, right? And that's your moment of inertia. And now what's the whole point of doing all this? To find the torque and moment of inertia is to find the radians, to find the angle, I guess. Right, but using this equation, we know that the sum of the torque is equal to the moment of inertia times alpha. Right, so now solving for alpha, we just have to divide the torque divided by the moment of inertia, which we already have above. So it's 0.54 over 0.090, and we get 6.0 radians squared. That's our alpha. Now to find the acceleration, we just need to do radius times the alpha. So 0.60 times 6.0, which is the alpha, the angle basically, and that's going to give us 0.36 meters per second squared. That is going to be our acceleration. That's going to be the acceleration of the cable, and that's all.